people mentioned before a right angle. So from here, from the parallelogram, there's a couple of things we could do. So I want you to imagine taking this parallelogram, and do you remember I showed you those wooden sticks last lesson that we could move the sides around? So I want you to take these two sides here like wooden sticks, and if you moved them so that you got a 90-degree angle, what would happen to your parallelogram? It would become a rectangle, right? We will get to the square, I promise, okay? So you can see here, here's my rectangle. It has the same properties that the parallelogram has. As we go from left, further evolved to the right, you're getting all of the things before, plus new stuff, right? So I still have my equal sides, my parallel sides. I still have my parallel sides. I still have my equal sides. But now I've added in a right angle, okay? Now, what's really cool about this is, just like before, see how here, what we added intentionally was parallel sides, and then for free, you get equal sides, right? Well, when you add one right angle, you'll notice everything else also becomes a right angle. You add one and you get the other three for free. It's like buy one, get three free. That's not a bad deal, right? So I've added a right angle, but in fact, I get 4. Okay? And this is our old familiar rectangle. Okay. Now I want you to remember, when we went from the quadrilateral to the trapezium to the parallelogram, right? What we had was one pair of parallel sides and then 2 pairs of parallel sides, right? Well, now I've got like 2 pairs of equal sides. What might be a natural next step to evolve this shape apart from adding a right angle? What else could we do? Yeah, Morgan. Yeah, fantastic. Not just that I've got pairs that are equal, but what if the pairs were equal to each other, right? So now I'm going to say, what I'm going to add is both pairs equal each other. Okay? So I already had a pair equal and a pair equal, and now the pairs themselves are equal. Okay? So what shape am I going to get now? I did hear it getting mentioned before. Remember, I haven't got the right angle yet, because that's over this way, right? I'm going to get a rhombus, so it's going to look like this. Okay, it looks like this, and I've got equal sides, but I also have all the other stuff that the parallelogram had, namely those parallel sides, like that, and like that. Okay, now, 2 things before we move to the very last step, because you can see I'm on the 4th column out of 5. Should name it, like we said, rhombus. It's got a silent H. Okay. You'll often see rhombuses, in primary school sometimes you call them diamonds, right? You'll often see rhombuses drawn like this, like they're standing up. I've deliberately drawn it the same way to help you see there's another evolution on the board that I kind of haven't connected yet. I've tried to draw them in a similar way so that you can kind of see the similarity. Anyone see it? Yeah, Adam.
I can.
Very good.
Yeah.
Can you see the kite, right? It's got those 2 pairs that are equal to each other, But now there's kind of like a line going from there to there, right? Yeah, it does look the same. The rhombus, just like being a souped up version of the parallelogram, the rhombus is also a souped up version of the kite. Okay? Before we leave off that and draw the last shape, I will, for example, show you things that the kite has that the rhombus has. Get your ruler out. You have to be very careful with this. If you've drawn your kite well, and this side sure enough equal, this side and this side sure enough equal, you can measure, see how close you are. Now what I'd like you to put on there is the diagonals of the kite. Draw the diagonals and draw them very carefully. So you've got this and this. Okay? Diagonals. Now, if you've drawn your diagonals well, you should see there's something special about those diagonals, right? They meet right there. They meet at 90 degrees. There's a right angle there. they're perpendicular, okay? Not only are they perpendicular, but can you see this one across the top, right? Can you see it's kind of been split in two? Can you see that? We have a special word for that. We call that bisected, right? It's divided into two. So we have this side here, this part of the diagonal, is equal to this part of the diagonal. Okay? That's kind of neat. You can prove that too. We won't go into it, but I just want to show you. Now, since a rhombus is a special kind of kite, let's do the same thing with the diagonals. Let's do them again. So we're going to put them down the middle like that, and then across the middle. Because the rhombus is just like the kite, number one, there's the right angle again. And number two, there's also this being split this way. But because the rhombus is even more special than the kite, there's something else you notice. Anyone see it?
It's parallel.
Yeah.
Above two lines above.
Yeah, very good. Here, one of the diagonals was split in half. One of the diagonals was bisected. But here, both diagonals bisected. I'm not going to do 4 lines because it starts to get a bit... Actually, I can do 2. I can do 2, can't I? I skipped over 2. There you go. Right. In fact, my rhombus is not very rhombusy. You can see it's not quite. But yours, you've got a rule in front of you, so hopefully yours will be better.
Hang on. All sides are equal?
Yes, that's right. All sides out here, and the diagonals are both been bisected. Okay. You can start to see our diagrams are getting very crowded, aren't they? That's because the more special your quadrilateral gets, the more cool stuff there is about it. Okay. Last step.
Where?
Do you remember, to go from here to here, we added a right angle, right? And to go from here to here, we made the sides all equal to each other, all right? So now I want you to think about, what happens if you add a right angle to this?
Square.
If you add a right angle to this, you add a 90-degree angle, okay? What you will end up with is our final evolution, our final version, right? The square, okay? You can see it's just like the rhombus in that you've got all the sides equal, right? You've got the right angles now, okay? You have all of those parallel things. You got this guy's parallel to this one's parallel to this one. If you want to, you can also draw your diagonals in. Okay. This time the diagonals, just like in the rhombus, the diagonals are perpendicular. But now, because this shape is even more special than all the other ones, right? Not only are these diagonals both bisected, but measure the diagonals. When you measure the diagonals with your ruler, you'll find that this diagonal is equal to this side, right? So you got this guy, and this guy, and this guy, and this guy. It's like everything is equal, okay? Alright, it's right, okay. It's not quite everything is awesome, but it is pretty awesome.
So square's like a perfectionist.
Yeah, kind of. Now, there's one more thing I forgot to mention, right? I can get to the square by taking a rhombus and adding a right angle. But that's not the only way I can get to the square, right? Sometimes a shape can evolve in more than one way. So you can see, if I go from the rectangle, what must I add to a rectangle to turn it into a square? Answer, both, yeah, the sides, these are already equal, but if I make them all equal, right? Both pairs of sides equal each other. You can see all roads lead to the square. Okay? And that is the most special quadrilateral of them all. Right?